So we need to find the radius of convergence and the interval of convergence of the given power series. Radius of convergence in power series is the radius of largest disk in which the series converges. The given series is right here, and from it we see that Cn equals square root of n. Then the formula for radius of convergence is 1 over r equals the limit of Cm plus 1 over Cm, where m goes to infinity. Then this equals the limit of the absolute value of square root of m plus 1 over square root of m, where m approaches infinity. Then this equals the limit of the absolute value of the square root of 1 plus 1 over m, where m approaches infinity. And this equals, so 1 over m approaches 0 because m approaches infinity, then this whole thing approaches 1. So we get that the radius of convergence equals 1. Then for the interval of convergence, if the radius of convergence is finite and non-zero, then the power series is convergent inside the interval. The absolute value of x minus a is less than r, where r is the radius of convergence. So we get that x minus a, where a is the first term of the series, so x minus 1 is less than 1, so x minus 1 lies between 1 and negative 1, then x lies between 2 and 0. Now we need to check endpoints. At x equals 0, our series becomes square root of n times negative 1 to the power of n, where n goes from 0 to infinity, which is alternatively p series, where p equals negative 1 over 2, so it's convergent. And at x equals 2, our series becomes the sum of square root of n, where n goes from 0 to infinity. Again, it's a p series where p equals negative 1 over 2, so again it's convergent. So we include both endpoints and we get that the interval of convergence is from 0 to 2.